You click it on, and suddenly a beam of light shoots forward like a perfect arrow. Clean, fast, simple. Now, here's the strange part. That light is supposed to be the freest thing in the universe. It has no mass, no weight, no reason to slow down. It just flies. But then I want you to look at your hand. Your hand is solid, heavy, stable. It doesn't fly away at the speed of light. It sits there like a stubborn object that refuses to move. And yet, your hand is made of atoms, and atoms are made of particles. And those particles, according to modern physics, are not little marbles. They behave like waves, and waves are exactly what light is. So here's the puzzle that should keep you awake at night. If everything is ultimately waves, then why does matter look like stuff? Why does an electron stay inside an atom instead of escaping like a photon? Why does energy sometimes behave like a trapped prisoner instead of a runaway beam? And now comes the dangerous thought. What if an atom is not? A tiny solar system, not electrons orbiting a nucleus like planets. What if an atom is something far stranger? What if an atom is actually light that has been trapped, not metaphorically, not poetically, literally, a standing wave, a locked vibration, a little cage of energy tied into a stable knot? If that's true, then matter is not made of substance at all. Matter is just light that forgot how to escape. And if we take that idea seriously, it doesn't just change chemistry. It doesn't just change quantum physics. It changes the entire meaning of reality itself. Because then the universe isn't made of particles, it's made of frozen motion. And today, I want to show you why this crazy idea might be closer to the truth than anyone is comfortable admitting. When you think about light, you usually imagine something simple. A beam coming from the sun, a bulb, a candle, or a flashlight. It travels, it shines, and it disappears. Light feels like the most free thing in the universe because it never stops moving. In fact, according to physics, light is the fastest thing that can exist. It moves at about 300,000 kilometers per second, and nothing can outrun it. It doesn't matter if you are standing still, running, or flying through space. Light always passes you at the same speed. That alone should already feel suspicious because it means light doesn't behave like ordinary objects. Now here's the interesting part. Light isn't just a glowing thing. It is energy itself moving through. Space is a wave. It's an electromagnetic wave, which means it is made of two fields, an electric field and a magnetic field, oscillating together. These fields rise and fall like a vibration, like a ripple on water, except there is no water. The wave exists even in empty space. That's one of the strangest discoveries ever made. You can have a wave with no medium, a wave that doesn't need anything to travel through. It just moves because it is a self-sustaining vibration of reality. But the question is, why does light move at all? Why can't light ever just sit still? Why can't you grab a photon and hold it in your hand? The answer lies in the nature of what light is. A photon is not like a bell you can stop. It is more like a traveling pulse of energy. The moment it exists, it moves. It has no rest state. It has no standing still mode. In fact, if light could stop, it would stop being light. Its entire identity is motion. That's why we say it has zero rest mass. Not because it is nothing, but because it cannot exist as a stationary object. Even more bizarre is the way light carries momentum. Even though it has no mass, it can push things. Solar sails work because photons hit the sail and transfer momentum. So light isn't just a wave that shines. It has physical influence. It can heat, push, and even change the behavior of atoms. Light can knock electrons out of metals. Light can bend in gravity. Light can behave like a particle and a wave at the same time. So you begin to realize something terrifying. Light is not just illumination. Light is not just something that helps you see. Light is one of the fundamental ways the universe stores and transports energy. And it behaves like a moving vibration that refuses to stop, like a perfect runner that never gets tired, never slows down, and never allows itself to become still. Now let's talk about something that seems completely different from light, an atom. An atom looks like the definition of stability. It's the building block of everything solid around you. Your bones, your phone, the air, the walls, all of it is atoms. And atoms don't behave like light. They don't fly away at the speed of light. They sit there, staying in one place, forming matter that feels permanent. But here's where physics becomes strange, because when you zoom in, atoms are not solid little balls. They are mostly empty space, and the particles inside them behave nothing like tiny objects. Inside an atom, you have a nucleus and electrons. The nucleus is extremely small, but it contains almost all the mass. The electrons exist around it, but not in neat planetary orbits like textbooks used to draw. Modern quantum physics says electrons are described by wave functions. That means an electron is not a dot moving in a circle. It's a wave of probability spread out like a cloud. It can interfere with itself, diffract, and form patterns exactly like light waves do. This is where the idea of standing waves enters the story. Standing wave is what happens when a wave is trapped between boundaries. If you pluck a guitar string, the vibration doesn't run away. It stays in the string, bouncing back and forth. The reflections interfere with each other and form a stable pattern. That stable vibration is a standing wave. It has nodes, points where nothing moves, and peaks, points where the vibration is strongest. This is not just a musical idea. It's a deep mathematical pattern that appears everywhere in physics. Now, imagine the electron inside the atom as not a particle orbiting like a planet, but as a standing wave trapped by the electric attraction of the nucleus. The nucleus acts like the boundary, like the walls of a tiny invisible cage. The electron wave cannot take any random shape. It must fit perfectly into the allowed space. If the wave doesn't fit, it cancels itself out. That means only certain wave patterns are stable. Those stable patterns are what we call energy levels or orbitals. This explains why electrons can't just sit at any distance from the nucleus. They are forced into specific quantized states, like musical notes on a string. The lowest energy state is like the simplest vibration. Higher energy states are more complex vibrations, and when an electron jumps from one state to another, it doesn't slide smoothly. It snaps. It changes its standing wave pattern instantly, and the difference in energy is released or absorbed as light. So the atom becomes a kind of resonance, a chamber, a tiny structure where waves are forced to lock into specific patterns. The electron is not in a place like a marble. It is a pattern of vibration. The atom itself is a system of trapped waves, like a microscopic musical instrument playing silent notes, shaping the matter you call solid. Now we reach the truly unsettling idea. If electrons behave like standing waves and standing waves are just trapped vibrations, then what exactly is matter? Because matter feels solid. It feels like it has substance, weight, hardness, and permanence. But if you follow the logic of quantum physics, matter is not made of tiny hard objects at all. Matter is made of energy patterns that have become stable. And once you see that, the line between light and matter begins to disappear. Think about what a photon is. A photon is a packet of electromagnetic energy moving freely through space. It's a traveling wave, always moving forward at the speed of light. Now compare that to an electron in an atom. The electron is also described by a wave, but unlike the photon, it does not run away. It stays trapped around the nucleus in a stable configuration. It's like the difference between a sound wave traveling through the air and the vibration locked into a guitar string. One is free motion, the other is frozen motion. So what if matter is simply energy that has been tied into a knot? That's not just poetry. Physics already hints at this. Einstein's famous equation E equals mc squared tells us mass is just a form of energy. It doesn't say mass contains energy. It says mass is energy. That means the stuff we call matter is simply energy concentrated in a particular way. Your body, the earth, and the stars are not fundamentally objects. They are energy held in place. And why does it stay held? Because of fields. The universe is filled with fields. Electric fields, magnetic fields, gravitational fields, quantum fields. Particles are often described as excitations of these fields. That means an electron is not a tiny ball sitting in space. It is a ripple in an electron field. A photon is a ripple in an electromagnetic field. And the only difference between these ripples is how they behave, how they interact, and whether they are trapped or free. When energy becomes trapped in a stable pattern, it gains properties like mass and inertia. It resists being moved. It resists being changed. It behaves like a thing. But it is still fundamentally motion, still fundamentally vibration. Just motion that has been forced into a closed loop. A standing wave doesn't travel away because it keeps reflecting back into itself. It is energy bouncing forever inside a boundary. In atoms, the nucleus and the quantum rules act like the walls of the trap. The electron wave becomes locked. The energy becomes localized. And when enough of these trap patterns combine, you get larger structures, molecules, crystals, metals, living cells, entire planets. Everything solid is built from these locked resonances stacked together. So the shocking conclusion is that reality might not be made of objects at all. Reality might be made of organized vibrations. Light is the free vibration. Matter is the trapped vibration. The difference between a beam of light and a rock may simply be that the rock is light that has been folded, confined, and stabilized into a pattern that refuses to escape. If you accept the idea that atoms are standing waves and matter is trapped energy, then you must accept the idea that the universe is a complex system that is governed by laws of physics. Then you start seeing universe in a completely different way. Suddenly, reality stops looking like a collection of objects and starts looking like a collection of patterns. Everything becomes less like a machine made of parts and more like a cosmic symphony made of vibrations. The universe isn't built from bricks, it's built from resonances. Think about a simple example, a soap bubble. A bubble is not made of something solid in the way a rock is. It's mostly air. But the thin film of soap forms a stable surface, tension that holds the shape. The bubble becomes a structure because the forces balance out. In a similar way, an atom becomes a structure because fields and waves balance out. The nucleus pulls, the electron wave spreads, and the quantum rules force only certain stable shapes to exist. The atom is like a self-sustaining bubble of energy. Now go even deeper. What holds these trapped waves together? The answer is interaction. Forces are not separate from particles. Forces are the language. The particles used to exist. Electromagnetism holds electrons in atoms. The strong nuclear force holds protons and neutrons in the nucleus. Gravity holds planets together. Each force is essentially a field, and fields are capable of storing energy in patterns. That means matter is not something sitting inside the universe. Matter is something the universe is doing. This is where the idea becomes almost terrifying. Because if matter is trapped light, then the difference between a photon and an electron might not be as absolute as we think. They could be different modes of the same deeper reality. In modern physics, particles can transform. Photons can turn into particle-antiparticle pairs in the right conditions. Matter can annihilate back into light. This is not theoretical. It happens in particle accelerators. It happens in nature. The universe constantly converts light into matter and matter back into light. So maybe the atom is like a cage built out of fields, trapping energy into a stable loop. And maybe the entire universe is full of these cages, these knots of energy, each one vibrating at its own frequency, interacting with others like instruments in an orchestra. The table you touch is not really solid in the classical sense. It's a dense web of electromagnetic forces, electron waves, and quantum vibrations refusing to overlap. Even your sense of touch is not you touching anything. It's the repulsion of electron fields. It's the resistance of trapped waves against other trapped waves. That's what solidity is, a force-based illusion created by stable energy patterns. And once you realize this, you start questioning everything. If all matter is just organized energy, then what we call objects are really just long-lasting events. The universe is not a place filled with things. The universe is a place filled with motions that have been stabilized into shapes. Every atom is a frozen piece of motion. Every molecule is a locked rhythm. Every solid object is a standing wave that has learned how to survive in the chaos of space and time. So if you really follow this idea to its edge, the boundary between light and matter starts to dissolve. What we call atoms may not be tiny solid objects at all, but stable patterns of energy that have learned how to stay locked in place. Light becomes the free form of energy, while matter becomes the trapped form. And reality itself starts to look less like a collection of things and more like a collection of vibrations refusing to fall apart. Nothing is truly still. Nothing is truly solid. Everything is just energy arranged in different ways. If this kind of thinking bends your intuition the way it bends physics, then you're not alone. This is exactly where modern science keeps pushing us, deeper into the idea that the universe is far stranger than it appears.